Okay, so June 2025, P3. In question 1, in part A we need to find g of f of 1. So we need to get f of 1. This is by replacing the x and the f with 1. So we replaced each x with 1. So 2 times 1 is 2. 3 times 1 plus 1 is 4. G of 2 over 4 is g of half. And g of half, we can get it by replacing the x in the g with half. So 4 minus half all squared. Half all squared is quarter. 4 minus quarter is 15 over 4. And in order to check this answer, actually in each question I'll show you in this presentation, I'll show you how I can solve it and the full solution to the question and how to check your results during the exam using your calculator. Okay, how to check this answer using the calculator? We can just rewrite it. So for example, g of f of 1, we can get f of 1 using the calculator. So 2x over 3x plus 1. Let's replace x with 1. So it's half. And now we can get g of half. So it's 4 minus x squared, replacing x with half. So the answer is 15 over 4 as we got. In part B, we need to find the range of f. There are many methods actually to find the range of f. One of which I prefer is the geometrical way. But before I start solving using the geometrical way, I'd like to inform you how to draw any reciprocal function. Any reciprocal function has this general form: ax plus b over cx plus d plus a constant term k, where a is the x coefficient in the numerator, b is the free term in the numerator, c is the x coefficient in the denominator, and d is the free term in the denominator, and k is the free term next to this fraction. In order to draw the reciprocal function, you need to get first the asymptotes, which is y equal a over c plus k, and x is negative d over c. How I got x? X is actually the factor of the denominator, which is the value which makes the denominator equals to 0. This is the x asymptote. So for example, let me give you a numerical example. In this question, it says 2x plus 1 over 3x minus 4 plus 2. I need to draw this. So in order to draw this, I got the y asymptote and the x asymptote as the formulas I given before. So let's now draw the two asymptotes. We have x equal 4 over 3, which is something like this, and y equals 8 over 3, which is something like this. And now my question is, will I draw this reciprocal function in the first and the third quads, or in the second and the fourth quads? In order to answer such question, you need to ask yourself about the product of 2 and negative 4 and 1 and negative 3. 1 and 3, sorry. So it has this shape. You need to check whether a times d is greater than or less than the product of b times c. So if AD is less than BC, you draw this function in the first and the third quad. And if AD is greater than BC, so you draw in the second and the fourth quad. So for example, in this one, we have AD like negative 8, and BC is 1 times 3, which is 3. Now AD, which is negative 8, is less than BC, which is 3. So we draw in the first and the third quads. So our drawing will look something like this. Back into our example, we need to draw this one to know its range. So to get the y asymptote, it will be 2 over 3 plus 0, because there is no a constant term next to the fraction. And x is equals to the negative 1 over 3, which is the factor of the denominator. And AD is 2 times 1, BC is 0 times 3. Okay, now I have all of the information. AD is greater than BC, so I'll draw in the second and fourth quads. And now let's draw the asymptotes. X equal -1/3, which is something here. 2/3, which is something here. And now my drawing is in the second and fourth quad, which is here and there. And since the domain is x is just greater than 0, so I need just to draw in this region. So drawing in this region, I'll eliminate this and eliminate all the negative ones. And now I have the range. The range is starting from the y, or the f of 0, and ending with y equals 2/3. So my range is between 2 points, which are f of 0 and 2/3. Let's check what's the value of f of 0. It will be just 0, so I corrected my drawing. It should start from 0 at x equals 0 and ending with y equals 2/3 because it's an asymptote. So that's my range. And actually, since 0 is in my domain, so it can be also in my range. So 0 is included in the range also. And that's the answer. Okay, how to check such answer in the exam? Actually, if you substitute x with the domain limits. So for example, 2x over 3x plus 1. If I substituted x with 0, I can get 0. And if I substituted x with a very large number, I should get 2 or close to 2/3. So let's solve this for something like 10 power 20, which is a very large number. It would be 2/3, so I am correct. Okay, in part C, I need to find the inverse function of f. And actually, when it says find the inverse function of f, it does not need only the inverse function, but it also needs its domain. So step 1, I need to replace f of x with y, and then I make x subject, and then I replace x with f inverse and y with x. So let's start with the first step. Let's replace f of x with y. And now, in order to make x subject, let's multiply both sides by 3x plus 1. Let's expand this y, it will be 3xy plus y. Let's make all the x's in one side, so I'll subtract both sides by 2x and also by y. Now I can take x as a common factor, divide both sides by 3y minus 2. I can now do the third and the last step, which is replacing the x with f inverse and the y with x. So replace x with f inverse and y with x. And actually that's my answer, and that's my domain. Actually, the domain of the inverse is the range of the function, or the original one. I just wrote it as it is. Okay, and this is the full solution. And actually, how can you check the answer in the exam if this function and this is the inverse of it? You can try to see that if the input of this is bringing you some output, if you took this output as an input here, it will give you the input. So for example, if f of any number gives you y1, if you input this y1, you should find this original number. So for example, let me try with you. So let's replace x with something like, let's say 1.3. The result should be 26/49. Now take this 26/49 here as an input. It should give you the input of the first, which was 1.3. So let's try x over 3x minus 2. Let's try to make 26/49 as an input. Yes, it gave me exactly 1/3, or 1.3, sorry. So these functions are inverse to each other. The input of any one of them is the output of the other one. Okay, now it needs me to solve f inverse equal f of x. So for the first time, you can say that you will just solve them simultaneously as they are, but there is a little bit easier one solution. I'll start with the more convenient one first. This is f of x, it's 2x over 3x plus 1. This is f inverse, which is negative x over 3x minus 2. In order to solve this, I can divide both sides by x, but first, before you do that, you need to check if x can be equal 0, and actually it can be. So back into here, if x is equals to 0, actually this is a solution, because when x is equals to 0, the left hand side will be equal to 0, and when the x is equals to 0 on the right hand side, the right hand side will also be equal to 0. So actually these two curves meet at x equals 0, and that's the first solution, that's the first intersection. In order to find the second intersection, we can multiply both sides by 3x plus 1 and multiply both sides by 3x minus 2. So that's 3x plus 1 will go here, and this 3x minus 2 will go here, and then we need just to expand those. So 2 times 3x is 6x, and 2 times negative 2 is negative 4. Here negative 1 multiplied by these, so I'll expand this negative, it will be negative 3x minus 1. And now let's bring the x's all together on the same side to be on the right hand side, so add both sides by 3x and add both sides by 4. So we have here 3 and we have here 9. So the other solution is x equals to 1 over 3. So we have two intersections actually. One of them is 1 over 3 and the other is x equals to 0. And actually you can see this here if we imagine this geometrical. This is the inverse function. As you can see, they intersect each other at x equals 0 and they intersect with each other once more at 1 over 3. The easier solution that I was talking about is that we can solve the real f of x with this line, because this line is the line of intersection, or it's always the line at which these two functions intersect. So instead of solving the two red curves simultaneously, we can solve it by solving the red one, which is f of x, with the blue one, which is y equals to the x. So I can say that the blue one will intersect with the f of x, and I can get the same exact answers at x equals 0 and x equal 1 over 3. So dividing both sides by x, this means that x can be equals to 0, and if I continue to solve this, I come up with x equals to 1 over 3, and that's the two solutions. Okay, how to check your answer in the exam? Actually, check if both points lies on both curves. So for example, this is f of x. It is 2x over 3x plus 1. As I said before, when x is equals to 1 over 3, the y will also be equals to 1 over 3. Same thing at 0. When x is equals to 0, y will also equals to 0. Same thing in the inverse function. So if I wrote the inverse function, like here, it's negative, yes, let me write it. It's negative x over 3x minus 2. Actually, if you replace the x with 1 over 3, you will get 1 over 3. And if you replace the x with 0, you'll get also the 0. So these are 2 points at which both curves intersect. Okay, question 2. It says, express the function in the form of r cosine x plus alpha, where r and alpha are constants, r is a positive number, and alpha is between 0 and 90. Okay, if you know the rule, I'll just use it, and if you don't know it, I'll show you the derivation of the rule. First, let me start with the ones who know the rule pretty well. It's r equals to the amplitude squared plus the amplitude of the sine squared under the square root. So r is equal to the square root of this amplitude squared plus this amplitude squared. It gave me 25. In order to get alpha, alpha is always just the shift or the arctan of the second term, the absolute of the second term, or actually the coefficient of it. So it's the absolute of the coefficient of the second term over absolute the coefficient of the first. It's always given like that. Okay, let's say that you did not know these rules or how they came from. Let me show you the derivation now. Actually, this will be my final answer. This will be r. I replaced it with 25, and alpha I got it with 1.287. If you don't know how these come from, okay, focus with me now. So 7 cosine x minus 24 sine x equals to r cosine x plus alpha. I need to write this in the form of this. Okay, now let me expand this cosine. It will be cosine cosine minus sine sine from the, and this formula is given in the formula sheet. Okay, now let me expand these r here and there. Now if you focus here, the coefficient of cosine x here is 7, and the coefficient of cosine x here is r cosine alpha. This is the first thing. The second thing is that the coefficient of sine x here is negative 24, and the coefficient of sine x here is negative r sine alpha. So I can use these two equations finding r and alpha. So 7 is equals to r cosine alpha, and 24 is equals to r sine alpha. Now I can divide these two equations, or solve these two equations simultaneously. In order to solve them simultaneously, I can divide them both by each other. R divided r, they will cancel out, and sine over cosine is just tan. Now tan alpha is 24 over 7, so alpha is shift tan 24 over 7, or arctan 24 over 7. That's why I say to you, or told you, that alpha is always the arctan of the absolute of the second over the absolute of the first. Okay, since I got alpha, I can back into any one of these two equations and substitute it and get r. So here r is 7 over cosine alpha. Alpha is shift tan 24 over 7, which is 25. And that's the answer. And that's the full solution. Okay, how to check if your answer is correct in the exam? Actually, you can check any value of x in the two expressions and they should be equal. So for example, let me say 7 cosine x minus 24 sine x at any value. Make sure that your calculator is in radians. So let me check this at a value like 7.9, for example. Okay, this is the value at x equals 7.9. Let me also put 7.9 here and check if these are two equivalent. So 25 cosine x plus 1.287. Actually, 1.287 is just an approximation. It's better to write it as it was, like shift tan 24 over 7. This would be more accurate. Let's solve this as 7.9. It actually gave me the same exact number. They are actually identical. Alright, and that's how I can check it. Okay, in the second question it says, using the answer to part A, find the minimum value of g. Okay, in order to find the minimum value of g, I need to maximize this denominator. Actually, 5 is constant, I cannot change it. 90 is constant, I cannot change it. Also, negative 3 is a constant, I cannot change it. The only thing I can manipulate, or the variable here, is f of 2x. In order to minimize this, I must maximize the denominator. And in order to maximize all this, I need f of x to be as small as possible because it has a negative sign. So in order to make f of 2x as minimum as possible, let's first check what is f of 2x. I know that f of x is 25 cosine something. So f of 2x is 25 cosine 2x plus alpha. Now I need to get the minimum value of f of 2 of x. So 25 is a constant, I cannot change it. Also 1.287 is a constant, I cannot change it. This cosine, I can change it. Cosine can actually take three values, -1 or 0 or 1. These are the extreme values that cosine can take. So in order to make f of 2x as minimum as possible, let's replace this cosine with a -1. So f of 2x will be -25. Let me replace this here. And now the minimum value of g of x is 5/90 plus 75, which is 1/33. Okay, now now I answered the first step or the first requirement. It wanted the minimum value of the g. The minimum value of it is 1/33. The second thing is that it wants at which value of x this occur. Actually, this occur when this term is equals to -1. This term was cosine to x plus alpha. Okay, so my question now is, when does cosine to x plus alpha will be equals to -1? Actually, this will occur when 2x plus alpha is equals to either shift cosine -1 or 2 pi minus shift cosine -1 from the ASTC theorem. Okay, what is about plus 2 pi n? I actually like to always write plus 2 pi n because, as you know, you can get the angle or the multiples of this angle with 360. So for example, the angle 30 is the same as 390 because the difference between 390 and 30 is just 360, and both solutions are correct. So that's why I like to say that each angle of those can be added or subtracted to 2 pi n, where n is an integers that can take -1, 0, 1, 2, 3, and so on. So let me show you how can I work this out. I need to get the value of x, so I subtract both sides by -alpha. And now I can divide both sides by 2. And now I can write this on my calculator and check the answer. And take care that I want the minimum positive one of them. So let me first write shift cosine -1 plus 2 pi x minus alpha, which is minus shift tan 24/7 all over 2. Let's try this at many values of n. So let's first start with n equals 0. It gave me 0.927, which is actually a positive value, but I don't know if it's the smallest positive one of the solutions. So let me try to replace this n by, let's say, 1. It got bigger, so I don't need that. Okay, let me replace it with -1. It became negative, so I don't need it. So the perfect one is when n is equals to 0, which gave me 0.927. And now I can, or I need to try the other way of solutions, the solutions in the fourth quadrant. So 2 pi minus this. And let me also try to replace this x or this n by 0, -1, and 1, and so on. So let me try 0. Okay, give me the same exact answer. Okay, let me try 1. Give me a high answer. I need the smallest one. Let me replace it by -1 and give me a negative answer. So the best thing is 0.927. This is actually the smallest positive one. Okay, and that's my answer. All right. This is the full solution you can write in the exam. Okay, how can you check whether this value is actually the minimum value of g? Actually, one of the best ways is to check whether if g dash at this x, which is this one, let me save it actually. So let's solve this at 0. If I want to save this number, let's call it a and solve a at the answer. So now whenever you write a, it will see it as 0.927. Okay, the best thing to make sure that this is actually a minimum point is that it's a stationary point, so the g dash at this location will give you 0. So let's make the calculator check the value of the gradient, which is d by dx of this function at x equals to a, which is 0.927. to 7. Let me write the gx like 5/90 minus 3 f of 2x. Actually, f of 2x is 25 cosine 2x plus alpha. Let me write alpha as it was, like shift tan 24/7. And now let me check the answer. The answer should be 0 because it's a stationary point. So let me write equal. Actually, it is 0. So I'm correct. I can actually make a better way of making sure that it's a minimum point by getting g double dash. And actually, g double dash at this location should give you a positive value. But actually, I don't have time for this. This is enough for me. All right. Now we go to question 3. It says find an equation linking this log y to this log x. Since this is a straight line, I can say that y equal mx plus c, but y is not y. Y is log y, and x is not x. X is log x. Actually, I replaced m with its rule, so it's y2 minus y1 over x2 minus x1. And this x is just log 10 to the base x, or log x to the base of 10, sorry. Okay, y2 minus y1 is negative 2 minus 0. Actually, c is the y-intercept, so I can easily write it as negative 2. Okay, y2 minus y1 over x2 minus x1, this is negative 2 minus 0 over 0 minus 3.5, and this simplifies to negative 4/7. And that's the full solution. Alright. Now, hence or otherwise, express y in the form of something exponential into the x. So let me write the expression I just got, which is log y is equals to negative 4/7 log x minus 2. In order to make y subject, I can say that 10 power those is the same as y. So y equals 10 power all of these. Okay, negative 4/7 is multiplied by log and is subtracted by 2. So I can say, or I can split these two, like this negative 2 can be written as multiplied by 10 power negative 2 to the same base of it. And now since this is a multiplication operation, so I can reform it like this, because power to a power is just multiply. So it's equivalent to what I've just written. 10 to the power of log x to the base of 10 is just x. And 10 power negative 2 is 1/100. So this is the form he wants. He said that p and q are rational constants, and actually these are rational constants. That's the full solution. Okay, in question 4, it says, if f of x is written like this, show that it can be written like this. Okay, so the first thing I saw here is that 7x is here and 7x is here. So I took 7x as a common factor because it will remain in the last step. So I took 7x as a common factor first. This makes this 7, and this will be 1. Now I factorize this one, of course using the calculator. So it's mod 5, 3, 1 equal, negative 12 equal. It gave me 3, which is x minus 3 as a factor, and negative 4, which is x plus 4 as a factor. So I wrote them. And now I can make common denominator. So by multiplying this fraction by x minus 3 up and down, I can now have a common denominator. Let me expand this. X minus 3 times 1 is just x minus 3. 7 minus 3 is just positive 4. X plus 4 will cancel out. And this is actually 7x multiplied by 1 is 7x. And that's the answer he asked for. And that's the full solution. Actually, you don't need to check your answer because it's a show that question. Okay, now it wants to find the differentiation of f. Since this, we can use a quotient rule here because this is a fraction. So the quotient rule says d n dash minus n d dash over d squared, where d is the denominator, n is the numerator. N dash means the derivative of the numerator, d dash means the derivative of the denominator. D is x minus 3, so let me replace it. N dash is the differentiation of the numerator, which is 7. N is 7x. D dash is 1. D squared is x minus 3 all squared. Let me simplify the numerator. So expand this. This will be 7x minus 21. 7x minus 7x is just negative 21. And that's the answer. Okay, how to make sure that this is the right solution? I can actually find the gradient at any value and check if this function give me the same answer. So for example, 7x all over x minus 3. Let's find, for example, the gradient at x equal 2. So it was negative 21. So let's check if also this function at 2 gives me negative 21. Actually it is, so I'm right. Question 5, it says the integration of sine squared 3x. Sine squared 3x can be written as half minus half cosine double the angle. Okay, I wrote this as a remember note. So remember that cosine double the angle is cosine squared minus sine squared. I can replace cosine squared with 1 minus sine squared. Negative 1 sine squared, negative 1 sine squared is negative 2 sine squared. And if I want sine squared to be subject, I can subtract both sides by negative 1. I can now divide both sides by negative 2. So negative 1 over negative 2 is 1 over 2. This will be negative half. This will be 1. So I can replace, whenever I see it, sine squared of an angle, I can replace it by half minus half cosine double the angle. So I've done this here. I replace this with half minus half double the angle, cosine double the angle. The integration of half is just half x. The integration of cosine 6x, let me first replace this as it is because it's a constant multiple, so it's negative half. And actually the integration of cosine 6x is sine 6x divided by the differentiation of the linear angle inside. So it will be sine 6x over 6 plus c. And that's the answer. If you want to check this answer in your exam, you can check this at any values. So for example, let me write sine 3x squared, let's say from 0 to, let's say, pi over 3. Oh, sorry. Let's write sine 3x all squared starting from 0 to pi over 3, for example. Okay, it gave me pi over 6. Let's check if this integration, if I integrated it from 0 to pi over 3, will it give me the same answer? Okay, let me check. So half times, let's say, a minus 1 over 12 sine 6a, yes, minus, open bracket, half b minus 1 over 12 sine 6b. Let's check the answer. Okay, let me replace a with pi over 3 and b with 0 because this was the limits I used. So let me replace a with pi over 3, so pi over 3, and let me replace b with 0. It actually gave me the same exact answer, which is pi over 6. So I can say that this one is equivalent to this one. Okay, so now question 2, it says, or the second part in question 5, it says the integration of x multiplied by x squared plus 4 all power 3 over 2. Now it's not easy to expand this, so I might think in the reverse chain rule. So what's the differentiation of x squared plus 4? It's 2x. but 2x is not existed here. So I can both multiply and divide by 2 at the same time. So the differentiation of x squared plus 4 is written next to it if I multiply both and divide by 2. And now the question is, what is the integration of this function to this power? Imagine it if you're seeing it like this. What's the integration of something power 3 over 2? It will be x power 3 over 2 plus 1 divided by the new power. I'll do the exact same thing here, as if 2x is not existed here actually. So the answer will be this half, I wrote it as it is, and x power 2 plus 4 I added to the power 1 and I divided by the new power. Actually 2 multiplied by 5 over 2 is just 5 downside, and that's the answer. I can actually check this using the same exact way I used in part A. So let's integrate this. Let me write it first, plus 4 power 3 over 2. Let me integrate this, for example, from 1 to 5. It gave me this value. Okay, let me check if this will give me the same value if I integrated it from 1 to 5. So let me replace it by a, then b. A squared power 5 over 2 all over 5 minus b squared plus 4 to the power of 5 over 2 all over 5. My limits was 1 and 5, so let's start a with 5 and b with 1. It actually gave me the same exact answer, so I am correct. Okay, in question 6, it says, find the value of A if you know that the temperature is 75 when the computer was switched off. And actually, T means the time after the computer is switched off. So when the computer is switched off, it means that the time is 0 or the initial condition. So let's use this info as when theta is equals to 75, the time was equals to 0 or the time didn't start yet. So I replaced this theta by 75 and this t by 0, and A became 54. I can actually replace this in the original equation. That's the full solution. Okay, in part B it says, given that also it takes 5 minutes for the temperature of the processor to decrease from 75 to 25. So in other words, it says that when the time is 5, the temperature is 25. So that's the info. It says that when the temperature is 25, this means that the time is 5. I replaced this here. Now it needs to find k to 3 significant figures. So let me first subtract 21 from both sides and then divide both sides by 54. Okay, first 25 minus 21 is 4. Let me then divide both sides by 54 and then len both sides. So len of 2 over 27 is just len 2 over 27, and len e to the power of negative 5k, it will be negative 5k. Now I need to divide both sides by negative 5, so k will be equals to negative 1 over 5 len 2 over 27. Actually, there is no need for this simplification, it just needs the answer to 3 significant figures, so it will be 0.521. Okay, the last thing is that it says, at time t capital, the temperature of the processor is decreasing at a rate of 9 per minute. So, find the value of t capital according to the model. Okay, the question says that d theta by dt, which is the rate of change of the temperature, when the temperature is equals to t capital, it will be negative 9. So let me get this value, and in order to get this value, I must differentiate this equation with respect to time. So the differentiation of theta with respect to time, it's just d theta by dt. The differentiation of 21, it's a constant, so it will be 0. The differentiation of this exponential function, it will be, let me replace this number as k. I'll replace it in the last step. but for just simplifying, I'll write it as k for now, but I'll replace it later. Okay, 54, I just wrote it as it is, like here. E power negative 5kt multiplied by negative k is the differentiation of this with respect to t. Of course, if I wanted to substitute t with t capital, this value will be negative 9, and this value will be t capital and not just t. Actually 0, it's negligible here, and negative 5 multiplied by 54 is negative 54k. Now I need to find t capital. So in order to find t capital, I can divide both sides by negative 1, and then divide both sides by 54k, and then ln both sides, and then divide both sides by negative k, and now I have t capital as this value. I can now replace k with its value, which is 0.521. Yes, I replaced the k with its value. I found this to be 2.90 minutes, which is the answer to 2 decimal places. Alright, how to check this in the exam? Okay, let me find the differentiation at this value, which is 2.19. Of course, it's an approximation, but it will work. So this is my function. It's 21 plus 54 e to the power of negative 0.521 t. This will be, I need to find this at t equals 2.19, and now the answer should be very close to negative 9. Actually, negative 8.988 is very close to negative 9, so I'm correct. Okay, question 7, it says, the curve has a stationary point at point P. Show using calculus that the x-coordinate of P is the solution of this equation. Okay, in order to find the stationary point, it can be found if I equated the differentiation of dy by dx with 0. So that's the first step that I need to do. dy by dx, let it be equals to 0. dy by dx to this function, it's a product function, so I can use the rule of the product function, which is the first times the derivative of second plus the second times the derivative of the first. The first is e power negative x squared. Derivative of the second is the derivative of sine 3x, which is 3 sine 3x. Oh, sorry, 3 cosine 3x, my bad. And the second function is sine 3x. The derivative of the first, it's an exponential function, so write it as it is, and then multiplied by the differentiation of the power, which is negative 2x. Now let me rewrite this, and now I can take e power to the negative x squared as a common factor, and now either this one is equals to 0, this term is equals to 0, either this term is equals to 0. So this term is equals to 0 when x is equals to infinity, so it's rejected. You know, e power negative infinity is equals to 0. E power negative infinity, which is negative, very high number, this is equals to 0. And actually, I don't need x to be equals to infinity because it's a trivial solution. Okay, let's focus about this one. When does this one equals to 0? Actually, as you can see here, I can see an arctan. So I came up with an idea of transferring this cosine and sine into a tan, of course by dividing both sides of the equation by cosine 3x. So this will be divided by cosine 3x, it will give me 3. And this divided by cosine 3x, it will give me tan 3x. And now I can get this tan as a subject first. So subtract both sides by 3. Divide both sides by negative 2x. Eliminate this negative. In order to make arctan, I can move this as an arctan or arctan both sides. And now this x, in order to be subject, I divide both sides by 3. And actually this is my solution. And that's the full solution. Alright. Here in part B, it says find x2 and x4 if you know that x1 is equals to 0.4. Okay, at n equals 1, I just replaced n with its value, which is n equals to 1. So x of 1 plus 1 is x of 2, equals to 1 over 3 arctan 3 over 2 times 0.4, which is x of 1, which is given here. The answer was 0.4367 because it asked me to get it in 4 decimal places. Repeating this here and there, I can find x2, x3, and x4 all together. And now the question says, using a suitable interval and a suitable function which should be stated, show that the x-coordinate of P is 0.430. Okay, let me ask you a question. In order to find the x-coordinate of P, if you remember, this was the equation I stuck with in order to get the x-coordinate of P. So if you remember, if I try to solve this equation, I can get the x-coordinate of P. But actually solving this equation is very, very hard. So I can use a numerical method. It's an easy numerical trick. If I subtracted both sides and say that it's equal to 0. So for example, if I subtracted both sides by 1 over 3 arctan 3 over 2x, the equation would be something like this, which means that the x at which satisfies this condition, in other words, the x coordinate of P, if it satisfied this equation, if it satisfied that this left hand side will be equals to 0, I can actually trust in this x. I can trust it as an answer to this equation, which actually was the original equation I needed to solve in order to get it. So if I tried to solve this and this brought me 0, this actually means that this x is equals to 0.430. So in order to write a suitable interval here, I need to find the upper and lower bounds of 0.43 and substitute them here. If there was a sign change, then I can trust in this solution. So let me try substituting. Let's call this g of x as x minus 1 over 3 arctan 3 over 2x. And don't forget our goal. Our goal is to find the x which makes this expression equals to 0. Okay, g of 0.425, which is the lower limit of this, give me negative a very small number. And g of 0.35, which is the upper bound of this, give me a positive a very small number. So since there is a sign change, and the function g of x is continuous in this interval, which is 0.425 and 0.435, then x coordinate of P is 0.430 correct to 3 decimal places is a correct solution for this function. Okay, question 8, it says, prove that tan 3x is equals to 3 tan minus tan cubed over 1 minus 3 tan squared. X is not equal to this, where n belongs to the integers. Okay, tan 3x can be written like tan 2x plus x, and I can now use the rule in the formula sheet, which is the addition rule for the trigonometric function tan, which is the sum over 1 minus the product. So it is tan 2x plus tan x, which is the sum, over 1 minus the product, which is tan 2x multiplied by tan x. I can now repeat the same exact process because tan 2x can be written as tan x plus tan x. So I can replace it by the sum over 1 minus the product again. So this is the sum over 1 minus the product, and this is also the sum over 1 minus the product. So tan x plus tan x is 2 tan x. 1 minus the product, tan x times tan x is tan squared x. I can repeat the same thing here. Okay, now in order to get rid of this complex fractions, I can multiply both the numerator and the denominator by this 1 minus tan squared x. Okay, so 1 minus tan squared x multiplied by this term, they will cancel out, and I'll be left with 2 tan x. And tan x multiplied by this, I'll just multiply them together later. The same thing downside, 1 minus tan squared x times 1 is just the same. And 1 minus tan squared is multiplied by this term, this will cancel out. and 2 tan x multiplied by tan x will be 2 tan squared x. Now I can get to this form easily. It will be 2 tan x plus tan x, this will give me 3 tan x, and tan x multiplied by negative tan squared will give me negative tan cubed, which is this one. Actually, here also, minus 1 tan squared minus 2 tan squared will give me minus 3 tan squared, and this is the one. Okay, and that's my answer. Okay, now hence solve this equation. Okay, it's easier to use, instead of solving a cubic equation, it's easier to replace this by tan 3x, sorry. So I did this in the first step. And it's easier to solve the tan with tans, so I use the identity to convert this sec into tan, which is 1 plus tan squared. And now I can expand. 2 multiplied by 1 is 2, 2 multiplied by 1 is also 2, 2 minus 8 is negative 6, subtract both sides by tan 3 theta, and now this is a quadratic function, so I can use mod 5 3 and write the values of the middle term. So this is 2, negative 1, negative 6. I can have that the middle term can be equals to 2, or the middle term can be equals to negative 3 over 2. So let me write these. So the middle term, which is tan 3x, it can be equals to 2 or equals to negative 3 over 2. Okay, now let's solve these together. The first thing, if tan 3 theta is equals to 2, let's start with it. So using the ASTC, we can say that 3 theta is equals to the shift tan of 2, or pi plus the shift tan of 2. Why is that? Because of the ASTC. The tan is positive in these two quadrants. And as you understand, I always like to write this, because this equation has an infinite number of solutions at the multiples of the 360s. And now I need to get theta, so I can divide both sides by 3. Yes, like this. I divided both sides by 3. And now I got these two solutions. How I got this? Let me do it with you slowly. So, shift tan of 2 plus 2 pi x all over 3. So let me replace this n or this x by 0, 1, negative 1 and all the integers, and find the solution which belongs between 0 and pi over 2. Actually, pi over 2 is almost 1.57, so anything between 0 and 1.57 is accepted for me. So let's solve this with 0. I got 0.37, which is to 2 decimal places, which is this solution. Okay, this is accepted for me. So let's try to decrease this by 1, so it's negative 1. Okay, this is rejected, so I'll ignore it. So 0, okay, I just did 0, 1, it's 2.4, which is greater than pi over 2, so I neglect it. Now the second interval of the solution, which is pi plus. So let me try this at 0. It gave me 1.42, which is actually accepted. Let me try this as 1. It's greater than pi over 2, so I rejected it. Let me try this also at negative 1. It's negative, so I rejected it. Okay, don't forget that we also have another solutions for negative 3 over 2. So I need to do the same thing, but for the negative 3 over 2. So I just replaced the 2 by negative 3 over 2. Yes, so I replace this here, I replace this here, I replace this here, also there, I replace this here, and replace this here. And now I found out that this is also another solution. So let me do it with you slowly. Let's replace this by negative 3 over 2. So let's solve this at 0. So it's not accepted. Let me try 1. 1.7, which is greater than pi over 2, which is not accepted. So there is no solutions in this interval. So let me try the pi plus. So at 0, actually 0.72 is accepted. Let me try 1. It's rejected because it's larger than pi over 2. Let me try negative 1. it's negative, so I rejected it. So I have only these three solutions. Okay, question 9. It says, find the exact value of y coordinates of A and B. If you see the figure, the x coordinate of A is 0 and the x coordinate of B is 0. So I can get A and B by replacing this x with 0. So I replaced x with 0. I just reversed the right hand side and left hand side. And now I can get y, but take care that y must belong between pi over 12 and 3 over 4 pi. So when you solve this equation, don't get all the solutions except the ones between those values. So I divided both sides by 2 over 3. I can now do the shift sign. So why I added this time pi n, not 2 pi n? Actually, because if you ask it yourself, when does the sign give you zeros? This actually occurs every 180 degrees. So for example, if I drew something like this is the sine wave. Actually, it brings me 0 once every pi or 180 degrees. So that's why the multiples or my multiples can be plus pi n, not plus 2 pi n. Because if I wrote plus 2 pi n, I won't get this one. I will just get this one thereafter. So I ignored this one. I don't need to ignore it. So that's why you will find me writing plus pi n. This is actually a special case with only the zeros. Okay, let me continue. So now I need to get y, so let me subtract both sides by pi over 4. And now let me divide both sides by 3. And now let me get the correct y values. So let me try with you using the calculator. So let's write this as negative pi over 4 plus shift sign 0 plus pi n in order to get all the multiples of the solutions all over 3. So let's try this at 0. Okay, it's negative 1 over 12 pi. Is this in the interval? No, so it's rejected. Okay, let's try another value, which is 1. It was 1 over 4 pi, and actually 1 over 4 pi is accepted because it's in this interval. Okay, let me try 2. It became 7 over 12 pi, which is actually also in this interval. If you try to get 3, you'll find yourself out of this interval. So A has the least amount of y and B has the most amount of y. So A is the small and B is the large one. Alright. Okay, so now let me proceed. It says show that dy by dx squared is equals to something in terms of x. Okay, so in order to get dy by dx, I need to differentiate both sides with respect to x. So the differentiation of x with respect to x is just 1. And the differentiation of sine 3y plus pi over 4, the differentiation of sine is cosine. The differentiation of this angle is the differentiation of 3y. And the differentiation of 3y is 3 times dy by dx. Now let me get dy by dx as a subject. So 2 over 3 multiplied by 3 is 2. Now let me divide both sides by 2 cosine. And now let me rewrite this. And now here is the problem. I need to get dy by dx squared not in terms of y, but in terms of x. So when I tried squaring both sides here, if you square dy by dx, it will become dy by dx squared. If you square this side, 1 squared is 1, 2 squared is 4, cosine squared is just cosine squared. Actually, I need to replace this y's in terms of x's. I need to get a relation between y and x, which is here. Okay, what relates x to y? The sine relates x to y. So I need to write this in terms of sine, not cosine. Actually, cosine squared is the same as 1 minus cosine squared, 1 minus sine squared, sorry. And now I can replace this sine 3y plus pi over 4 as 3 over 2x, because I can get the sine subject here. So if I try to make the sign subject here, it will be 3 over 2x. And now I can replace this sign by 3 over 2x all squared. And now I have this form. But then 3 over 2 all squared is 9 over 4 or x squared. Let me multiply this 4. So 4 times 1 is 4. Multiplied by 9 over 4 is 9. And that's the answer. Okay, what can I do in order to check whether this answer is correct or not? Actually, I can find this using this equation. I can tell the calculator to differentiate. Okay, but I need something. I need to make y subject because the calculator I can put here the y only. So let's make it subject from this step. So let me write shift sign because I need to write the y as a subject, you know. Okay, so let me write shift sign 3 over 2x. Pause the video and try to make y subject, and actually you can then understand what I'm writing here. So it will be shift sign 3 over 2x subtracted from pi over 4, and all of these things will be divided by 3. So let me divide all of this by 3. Yes. Okay, let me check the value of this thing at any x. So for example, let me try x as pi over 3, for example. Okay, let me try pi over 4. Oh no, so pi over 5. Okay, so at pi over 5, this is the answer. Okay, let me check whether this value will give me also this one. So let me try root 1 over 4 minus 9x squared at x equals pi over 5. Will it give me the same gradient? Actually, yes. So my constants are correct. Alright. Very well. Okay, in the last part, it says the normal to C at A. Okay, I tried to draw it here. So if this is A, this is the tangent to A. So this is the normal of A. I drew it in order to easily imagine this. The tangent of C, the tangent of the curve at B. So I drew a tangent at B. It said that they intersect at D. So these two lines, which is the normal of A and the tangent of B, they intersect at D. So using the answer to part B and the sketch in the figure, find the simplest form for the exact x coordinate of this D. Okay, one way to solve this question is that you get the equation of the normal and get the equation of the tangent, and if you try to solve them simultaneously, you will get the x coordinate of D, or all the coordinates of the action. Okay, I wrote this here. I wrote that I need to find y equals to mx plus c for A, which is the normal of A. MNA means the slope of the normal to A, and MTB means the slope of the tangent at B. But then I saw an easier way, because this C is easy to be got from the graph, because C is the y-intercept, and actually the y-intercept is the y of A. So I replaced this C with the y of A, and actually the same thing happened here. This tangent, it's C, it's the y-intercept of B, so it's the y-coordinate of B. And now, since this question needs only the x-coordinate of D, I did a little trick here. I assumed that if D has the coordinates of x of D and y of D, and since D lies on both these two lines, so it satisfies both of these two lines. So I can replace y with yd and x with x of D, same thing here. And now, since the left-hand side is equals to the left-hand side, So certainly the right hand side is equal to the right hand side. And from here, I can solve this and get the x of d. But let me first make it as a subject first. So let's subtract both sides and get all the x of d's in the left hand side. So let's move this by a negative sign and move this here by a negative sign. Yes, and move this here by a negative sign. And now let's take x of d as a common factor. And now let's divide this here. Now I'm almost done. The y of b, I got it in part A. The y of a, I got it in part A. The slope of the normal to a and the slope of the tangent of b, I can find them using dy by dx. So the y of b is 7 over 12 pi. The y of a is 1 over 4 pi. And now the slope of the normal is negative dx by dy. The slope of the tangent is dy by dx. Of course, this is at A and this is at B, don't forget this, because I'll need this later. Okay, now I ask myself a question. I have two forms for dy by dx. One of them, from my point of view, this is the easiest one in order to find dy by dx, but it wanted me to use this one, which is the answer to part B, which is dy over dx whole squared is equals to 1 over 4 minus x squared. Actually, I didn't like to use the answer in part B. I don't know if this is right or wrong, but I'll tell you how to use it. But I prefer this one. I'll tell you why. Because since this is squared, when I try to find dy by dx, I will stuck with positive or negative square root. And I don't know whether I'll take the positive part of the square root or the negative part of the square root. I must then check the sketch and how the sketch looks like. Maybe that's why it said using these two things together. Because actually, let me show you something. Of course, you know that the x of a and the x of b is both 0. So if you substitute x with 0 here, you will get 1 over 4, right? And now, if you square rooted both sides, you will get positive or negative half. So the question you must ask yourself, whether the slope of the tangent of positive half is for A or B. And actually, this can be sensed from the graph. So the slope of A is the negative slope because it's going down. It's the slope of negative half at A. And the slope of the positive half will be at B. But this can only be figured out if you can see this graph. That's why I like to use this one. It's more safe because you need here to substitute with y. And actually y of A is 1 over 4 pi and y of B is 7 over 12 pi. It's so direct. It's so straightforward. So you will see me that I use this one, but actually this is doable with this one. Okay, and now I just got dx by dy because I need dx by dy and also dy by dx. So if you need dx by dy, I use this expression with y equals to the y of a. So I replaced this y by pi over 4. The same thing will be done here. I expanded this. This is dy by dx. So I'll use this one, but at y equals 7 over 12 pi. And now let me simplify this. This will be negative 2. This will be half. And actually, if you simplify this, it will be 2 over 9 pi. And that's my answer. There are many ways to check whether this answer is right or wrong, but one of them is that you check if this point lies on a line whose gradient is, or the reciprocal, the negative reciprocal of its gradient is negative half. One of ways to check whether this pointer is correct or not. Okay, the last question, question 10, it says, figure 3 shows a sketch of part of the graph with the equation y equals f of x, where f of x equals to the absolute of kx minus 10 plus k. It wants me to find the y coordinate of A, So this is easy, I just replace x with 0. So replacing x with 0, so this will be absolute of -10. Absolute of -10 is just 10. And this is the y-coordinate of A. It just wants the y-coordinate of A. Okay. And the x-coordinate, okay, the coordinates of B. So the coordinates of B, I can get it by, the x-coordinate of B is just the factor of the absolute. Okay, what's the factor of this absolute? Factor means the value of x, which will make this expression equals to 0. So when x is 10 over k, this will be 0. And actually when x is equals to 10 over k, this value of y will be equals to k. So if you replace this x with 10 over k, this will be 0. And when this is 0, y equals to 0 plus k, which is k. And that's the coordinates of B. Okay, now it wants me to find the range of values of x which satisfy this inequality. Okay, in order to satisfy this inequality, so let me subtract both sides by k. I did this fast, so both sides minus k, this will disappear, and this will be just k. Okay, in order to solve this inequality, I need to get rid of this absolute. Okay, in order to get rid of any absolute, you need to assume two things. Whether the domain of the absolute is the positive domain or the negative domain. So first you assume that if x is greater than the factor of the absolute, what will be the value of the absolute, whether it will be positive or negative? So for example, if x is greater than 10 over k, and you replace this x by a value whose value is greater than 10 over k, whether the value inside the absolute will be a positive or a negative one, it will be a positive. So that's why I removed this absolute and replaced it by a positive kx minus 10. The exact opposite thing will happen when I do this. If I put the x with a value less than the factor of the absolute, if I put x less than 10 over k, this value inside will be a negative value. So that's why I replaced this one with a negative value. So this kx will be negative kx, and this negative 10 will be a positive 10. And now I can solve these two inequalities simultaneously in their domains. So they must satisfy their domains actually. So let me solve this. Add both sides by 10. And now divide both sides by k. K over k is 1. 10 over k is 10 over k. So what's this here? This says that x must be greater than or equal 1 plus 10 over k. And actually this makes sense. And actually this is acceptable, because I'm only accepting the values of x which are greater than 10 over k. Since these values are actually greater than 10 over k, which is 1 plus 10 over k, so I will accept this as it is. Okay, so this is the first part of the question. Here, let me also get x, so let me multiply all the equation by a negative. So negative times negative kx is kx. Okay, I first subtracted both sides by 10. Okay, so let me then multiply these inequality by a negative, and of course when you multiply an inequality by a negative, you replace or you reverse this sign. So let me divide now all the inequality by k. Negative k over k is negative 1, and this is negative 1 plus 10 over k. Actually, this solution is accepted. Why? Because this solution lies in this domain. So this domain is only accepting the solutions if x is less than 10 over k. And actually, this value is actually less than 10 over k, because it's negative 1 plus 10 over k. So these are two solutions for my question. So the range of values are x less than negative 1 plus 10 over k, and x is greater than 1 plus 10 over k. Okay, given that the line with the equation y equals 3x plus 1 intersects the graph of y, which is f of x, at 2 points, find the range of values of k. Okay, let me imagine this with you first. This is the line whose equation is equals to y equals 3x plus 1. of course its y-intercept is at 1. And if you remember, in part A, I got the coordinates of A as 0 and 10 plus k, and the coordinates of B as 10 over k and k. Okay, in order to solve this question, I like to solve it graphically. There is an algebraic long way, but I won't say it in this video. I'll just say the graphical way. Okay, so this makes sense. This line can intersect with this function twice if and only if this line is touching this one and also this one. So the extreme positions is this point. If this line just touches this P, then I'll have only one point of intersection. Also, the other extreme position is when this line is parallel to this one. If this line became parallel to this one, I'll be ending having only one intersection. So these are my extreme positions. This is the first extreme position, which is one intersection, and this is the second extreme position. So my solution is between these two. If my line is just between them, like this, then this is the perfect way of my answer. Okay, let me first assume this. Let's assume together if this point lies on the line. When does this occur? Let's check. Y equals 3x plus 1. Let me assume that if this point lies on this line, so it satisfies the line, when will this happen? This will happen at k equals 6 and k equals -5. Actually, -5 is rejected because in the question it says that k is just a positive constant. So I'll choose k equals 6. So when k is equal to 6, this line will intersect with this curve only once. Okay, let me check the second extreme position, which is when will this line be parallel to this one? Okay, how can I know that? What is controlling the slope of this line I'm pointing at? It's actually the slope of this value itself. Since f of x is equals to kx minus 10 plus k, this k, as you can see, it's the coefficient of x. And as you know, the coefficient of x is the slope of this line. So actually, the extreme position will be if this k is equals to 3 and also the slope is equals to 3, this is my second extreme position. So I need my k to be in between these two extreme positions. I need it to be in between the 3 and the 6. Don't forget to subscribe to our channel to check all the new solutions, and that's all for this exam. Thank you. جميل ما مريد بيه، جميل ما مريد بيه، تعال شو